take a look at the work that we did and just get some answers. So we'll go ahead and actually work through these problems now so that we feel completely comfortable and ready for the test that we are going to be taking next week. So problem number 1, we've done a few versions of this problem, and again, it's simply the problem of an object, two objects traveling at constant speed. We want to know which object is going faster, A or B, and of course the answer here is object B because the slope is steeper. I won't require you to state that. What I will say is the way we're going to prove this is by getting the velocity of each object. So let's just kind of be clear in our calculation. So I see a lot of you doing rise over run calculations, and I'm worried that you're getting a little sloppy with your work. So the time coordinate is 6 and the position coordinate is 4. And then here the position coordinate is 0. Sorry, the time coordinate is 0 and the position coordinate is 16. So if I'm going to get the velocity of object B, I'm going to do the rise over the run, or the actual calculation, which is y2 minus y1. In this case, this is x2 minus x1 over t2 minus t1. So that's over 6 minus 0. So that's going to be negative 12 divided by 6. And that's going to give us negative 2 meters per second. I do need the negative sign. You will be marked off points if you don't include that, so be really careful. I need to know that you know the object is moving backwards. So for object A, again, also at the point 6, 4, but it's starting from 0, 10. So the velocity of object A is going to be, again, 4 minus 10 over 6 minus 0, and that's giving us negative 1 meters per second. So to get the displacement of each object after 6 seconds, let's be really clear. The definition of displacement is, so delta x for A, the displacement of A is going to be xa final minus xa initial. And let's actually plug in those numbers. That's going to be 4 right here minus, and I'm actually going to call it xa final just so you're clear on that. And xa initial is where you start at 0. Initial means from time equals 0. So that's 4 minus 16, and that's going to be negative 12 meters. I've done enough of these calculations that I'm just going to go ahead and actually write down L delta XB. I'd want to see it work for at least one of these, though. That's going to be negative 6 meters. And when we plot the velocity, we're just going to plot the slope of the graphs that we got in the slope that we calculated in part B. So the velocity of object B is negative 1 meters per second here. And the velocity of object A is going to be this negative 2 meters per second that we get down here. All right, so that's problem number 1, and we'll take a look at problem number 2 in the second video.